Alright, we'll start this video. Area. So topic is area. So what is an area? The total surface occupied by an object is called its area. So the total surface that is occupied is called area. For example, width over here. So whenever you find an area, we find product of measured length of two sides. So any two sides we measure. Okay, it's a two-dimensional figure. So we measure length and breadth or length and width. So the length is 3 and width is 2. We multiply length and width, and whatever the amount we get, it's a area, that is this shaded portion. All right. Okay. So there are few examples over here. So 5 meter and 2 meters. Okay, so the area is 5 into 2, that is 10 meters square. Now what do you understand by this 10 meters square? Or over here, this is centimeter, 4 centimeter and 4 centimeter. So area is 4 into 4, that is 16 centimeters square. So when you say that this is 10 meters square, okay, meter square, that means that there are 10 squares that are of meter size. Okay, so suppose this is 2 meter, you divide it into two parts, and this is 5 meter, you divide it into 5 parts. 4 plus 5. Okay, now if you see, suppose this is 1 meter, 1 meter, 1 meter, 1 meter. So okay, so this is a square that is of 1 meter each. So if you say there is 10 meter square, that means you have 1 2 3 4 5 6 7 8 9 10 squares. All right, so this, when you multiply this, that means that area is 10 meter square. That means you can fill this place with 10 such squares. Okay, that is of meter length. Here, when the area is 16 centimeter square, you can fill this box with 16 squares that are of centimeter length. So one square is, one side of that square is of 16. So suppose this is 4 centimeter, you divide it into 4 parts. Okay, and this part also you'll divide it into 4. So if you'll count the number of boxes, they will come to 16. Each box, okay, the side is 1 centimeter. Okay, that's why when you say centimeter, that means there is, every box is of 1 centimeter size. There's a square box, and how many square boxes we have? We have 16 square boxes of 1 centimeter each. Here we have 10 square boxes of meter. Okay, one side is of meter each. All right, here we'll get it some clear picture from other examples. An SI unit of area is meter square. Okay, so SI unit is meter square. All right. Okay, the same example. So if the unit is mentioned, if it is centimeter, okay, 6 centimeter, if 6 square centimeter, that means each box would be of, each box would be of centimeter. Okay, if it is meter, in that case each box, the side is of meter length. All right. Okay, few examples just to see. So if you have length 8, so 8 anything, centimeter or meter, and if you have 4, say centimeter, and 8 centimeter, in that case 8 4s are 32. So your answer would be 32 square centimeter. Okay, since the values over here are in centimeter. If the values would have been in meter, your answer would have been 32 square meter. That simply means that if you count the number of boxes, okay, that is this total area is covered by how many boxes? Is covered by 32 boxes. Each are of, are square, that is of 1 centimeter, because it is in centimeter, so it was 1 centimeter. All right. All right. Area of a regular shape. So regular shape, we know we have the formulas. For area we have length into breadth. Okay. For triangle we have half base into height, and for circle we have pi r square. All right. Multiples and submultiples. So multiples. So unit, we know the SI unit is meters. Multiples would be more than meters. So 10 meters into 10 meter, that is 100 meter square, that is 1 r, is 100 meter square. Similarly, 100 meter into 100 meter would be 1 hectare, that is 10,000 meter square. Similarly, 1 kilometer square is 1000 meter into 1000 meter. That would be 10 to power 6 meter square. Okay, so this 60, so it will be 10 to power 6 meter square. Alright. Similarly, sub multiple less than meter. So 10 centimeter into 10 centimeter, that is 100 centimeter square. That is called as 1 decimeter square. Similarly, 1 centimeter square would be how much meter square? So we know that 1 meter is equal to 100 centimeter. So we can say that, okay, 1 meter is equal to 100 into 1 centimeter. If you have to calculate the value for 1 centimeter, we have to set this 100 on the other side. It will be 1 upon 100, right? 1 upon 100 meters. So 1 centimeter is 1 upon 100 meter. Okay. So 1 centimeter square is, so 1 centimeter square is nothing but 1 centimeter into 1 centimeter. 1 centimeter is 1 upon, here, 1 upon 100 meter. So what we have written over here, 1 upon 100 meter. Again another centimeter, 1 upon 100 meter. This, when you multiply, it becomes 1 upon 10,000. So there are two zeros over here, two zeros. So here it will be 4 zeros. So it will be equal to 1 upon 10 to power 4. That can be written as 10 to power minus 4 meter square. So 1 centimeter square is 10 to power minus 4 meter square. All right. 1 millimeter square is, so we know that 1 meter is 1000 millimeter. Okay, so 1000 millimeter. So 1 meter would be, it will be 1 millimeter would be 1 upon 1000 1 upon 1000 meter. So 1 millimeter is 1 upon 1000 meters. So again 1 meter square, you'll multiply it twice. So 1 upon 1000 meter into 1 upon 1000 meter, that will give you 1 upon 6 zeros. So that will be 1 upon 10 to power 6 meter square. That will be nothing but 10 to power minus 6 meter square. So once this comes up, it becomes minus sign, 10 to power minus 6. Alright, just one more quickly. So 1 meter is nothing but 1000 millimeter. Okay, so 1 meter can be written as 1000 into 1 millimeter. We'll take on the other side. So 1 upon 1000 meter is equal to 1 millimeter. Now here we have millimeter square. So 1 millimeter square is nothing but 1 millimeter into 1 millimeter. So you'll multiply 1 millimeter, 1 millimeter. So here you are multiplying 1 millimeter square is 1 millimeter into 1 millimeter. Okay, so 1 millimeter into 1 millimeter. 1 millimeter is how much? So 1 upon 1000 meter. So you substitute that 1 upon 1000 meter. Again 1 millimeter is 1 upon 1000. Okay, and after that it comes to 10 to power 6. Alright. Volume. Okay, now we got to know the area. Area is the surface covered. We can cover it out using the number of squares. So if you have length and breadth, you multiply length and breadth, and you know how much squares are there in that. Okay. Now, how you'll find your volume? Volume is a three-dimensional figure. Okay, it has length, breadth, and height. Okay. So how you will cover it in two dimension? That is a surface. So it has to be something different. Okay, because there is a space inside it. Okay, in a volume there is width, height, length. Okay, so there is a space inside. There is a space occupied by an object. So this we will do it by in a form of a cube. So in volume we multiply. So volume, the formula is length into breadth into height. So we multiply all the three things. So for example, over here, this is 4 inches or 4 centimeter. Take for example. So this length is 4, breadth is 3. Okay, there are 3 cubes. 1, 2, 3 cubes. So 3, 1, 2, 3, 4, 4 cubes. So 4. So 4 into 3, and height. See, height we can't see because there are no cubes over here. But here they have given us 5. So this is 1 cube. Similarly, on it there will one more, another cube will come, another cube, another cube, another cube, and this will fill up. So this will be 5. Oops. So this is 5. Okay. Now we will multiply. It will come to 5 threes are 15, 15 fours are 60. So this will be say 60 centimeter cube. Okay, so what does this means, this number 60? 60 means that there are 60 cubes. Okay, and each cube is of, one side is of centimeter. So cube, so length, okay, so that small cube, this small cube, it has length 1 centimeter, breadth 1 centimeter, and height 1 centimeter. Okay, such cube, okay, 60 such cube would be required to fill this entire box, which has volume 4, 3 and 5. Alright, so this 60 means, the volume means 60 such cubes would be required to fill this entire area. Alright, I'll show you another example, you'll find it better. Okay, so over here we can count the number of cubes and get the answer. For example, over here you have how many cubes over here? So 1, 2, 3 cubes over here. 1, 2, 3. Okay, so length 3, 1, 2, 3 cubes over here, 3, and our height is also 1, 2, 3. Okay, so if you see, it's beneath this 1, 2, 3. So the area is, volume is how much? 3, 3, 3. So 3 threes are 9, 9 threes are 27. 27, whatever the unit would be, it will be in cubes. Say for example centimeter, so centimeter cube. All right. So that means there are 27 such cubes you can fit inside it. If you'll count, see 1, 2, 3, 1, 2, 3, 1, 2, 3. That means at one slab we have 9. On the second slab, if we'll form a second slab over here, it will also form 9. And the third will also form 9. So 9, 9, 9, it will come to 27. Similarly, this is the another example. So I hope you understood the concept. These are some other examples. So easy one, 4. So this is a cube, 2, 2, and height is 2. So you know how much 2 2s are 4, 4 2s are 8. So this will be 1, 2, 8. So 1, 2, 3, 4, and beneath that 1, 2, 3, 4. So 8. So 3. So this will be 27. Again, the way we already did this. Right, this is another example. Another example, the same concept. All right. This is another example, easy. So 4 cubes over here. It's a colored, so you can understand 3 cubes over here and 2 is this. So this is how you find the volume of any object. Now it is one dimensional. Okay, so when you are finding length, it is one dimensional, 1D. That means you only need one unit. Okay, just to measure on the number line, you just need one x-axis. Okay, only on x-axis you can find all the values. Okay, for length. To find area, you need two axes, that is x-axis and y-axis. Hence, it is called as a two-dimensional figure. And to find a cube, you need three axes. Okay, so x-axis, okay, y-axis, and z-axis. So it is called as a three-dimensional figure. Hence, it is meter cube, meter square, and meter. All right. It has become lengthy now. Perimeter. Perimeter is just the outer area. Okay, just for differentiating so people, perimeter, that means the outer area, outer part. Okay, outline, you when you calculate the outline, that is called as perimeter. Area is the surface. Okay, the entire surface, the shaded portion you calculate, that is the thing that is in yellow, that would be area. And volume, when you fill the entire thing. Okay, so if suppose this box is hollow, in that case if you fill it with a liquid, say water, that will be the volume of it. Okay, so there are some things that we use for measuring volume: beaker, measuring cylinder. These are the other examples. Okay, this you use for measuring kerosene. Okay, for measuring milk. Measuring cylinders we see in our labs. Okay, and we measure using the lower meniscus, the lower part of it. Alright, so that's it. I'll stop it over here. It has become very lengthy. Bye now. Take care.